Hello, this is Dr. Ma, and today we're going to talk about the system of equations, okay, linear equations. Okay. And these are the objective we will get to. Okay, we started with, suppose we find a receipt that says 2 hamburgers cost $4, then it is easy for me to figure out that 1 hamburger costs $2. Okay, however, if I get a receipt with 2 items on it, and I don't know the price of either, and 2 burgers and a fry, and they cost $7. Now I cannot backtrack because there are too many different possible answers. However, I can nail down which answers, the particular answer if I have another piece of receipt, of another piece of independent information. Then I can backtrack to figure out what X is, what Y is. Okay, we'll do that shortly. In general, then in mathematics, then we have the following principle that if you have n different letters, you need to find out n variables, then you will need n receipts, okay? Independent one, quote unquote. Okay, and here's how we do it, and how we solve to backtrack the price of the burger and the fries. And these are the two pictures for the two orders. Then if you take a look at it, say, oh, gee, wait a minute. And the difference in the order is a hamburger, and difference in the price is $2, or the burger is $2. That's it. This is called elimination method. Okay, it's also called the addition subtraction method. Okay, and the PowerPoint starts from here and shows you how you set up equations in X and Y's and carry through the calculations that follows exactly the logic we went through. And here's the example for the ones with the burger, fries, and the drink. Okay, and how we do that, and okay, and once you start doing this, and you'll find out, wait a minute, then a lot of calculations and all this X and Y and Z's all over the papers. Can we track them easier? And the answer is yes. Okay, we just track them as tables. Okay, equations with X, Y numbers, and you can just easily put it into a table like in the Excel sheets. Excel has column A, column B, and here's column X, column Y. You store the number, how many X, how many Y's, and then you have a column for numbers. So solving equations, manipulating X's and Y's, is the same as manipulating these rows of numbers. Okay, and what do we want to do? Well, these are the things we want to do. Okay, these are the things we are allowed to do. Let me rephrase that. We can switch two rows without changing the answer of the system. We can multiply a row by a number without changing the answer of the systems. It's still a different looking system, but it can still give you the same answer. I can add a multiple of a row to another row this way, okay? I also get a system of the same with the same solution as before. Okay, so armed with these 3 steps, okay, it's like playing a game and jumping around with these 3 steps. And what we do is, suppose when I start with the systems, I write it into a table of numbers. Then I use the steps I just learned, and adding row to another row. So, and keep manipulating the rows until this new matrix, until the matrix look like this. Okay, everything down below 0. Okay, and why? Okay, here's example what we do. I put the equations into a matrix, and the bottom, the shady yellow part is the part I want to get 0. So I do various steps, swap rows. I add a multiple of a row to the second row to get a zeros in the very beginning and the second row. Then I keep getting more zeros, adding rows to another row, blah, 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 blah. And voila, I'm at that stage. Okay, and what is that? Well, gee, Now it's easy for me to go back to get the answer. How? I start from the bottom row. The bottom row says Z is 1. That's exactly what I said. That's a column Z, so 1Z is 1, so the Z is 1. Put the number 1 back into the second row, the one on top. And then I can take out the Y. Putting Z and Y into the first row, the numbers 1 and 2. I take out the X. Okay, so this is how we systematically use these matrix manipulating the row to get to a answers. Okay, so this is a one matrix method. Okay, now continue. The two cases which are kind of strange. Okay, suppose I find a receipt and 2 burger for $2. Okay, now 1 burger is $1, $2. So that's no problem. But suppose now I find 2 receipts on the ground and I take a look at the 2 orders, then I realize these 2 orders are exactly the same. And one, except the order number 2 is double of the first order. You know, for $7 become 14, 2 burgers, now it's 4 burgers, 1 French fry now become 2 French fry. Okay. In other words, these 2 pieces of information are the same, so I cannot use the system from these 2 pieces of receipt to backtrack the X and Y's. Okay, so same information. So the second piece of information is useless. Okay, one of them is useless. You get a pick. Okay, and these kind of systems we call these redundant or dependent systems. Then at the other end of the logics of what could happen, or what could go wrong without finding the answers. Here's the other case. Okay, and you find a receipt, 2 burgers, receipt 2 burgers, 1 price $7. And the second receipt says 4 burgers, 2 fries. But then you look at the price, it's $15. The one order, the second order, you go back to the shop. Systems, okay, contradictory calculations. We call these contradictory informations or contradictory systems. Inconsistent systems. Okay. So the PowerPoints basically show you what the matrix manipulations, if you were to do the matrix, perform row operations, and what were the matrix, their matrix is what it will look like at the end. Okay. And that's it. Okay, so these are the first two sections on the system equation in a special case of system of equations. Okay.